Hello, everyone. Good afternoon. Welcome and thank you. We are going to start Freit's TechSpeedDating webinar, and just a quick rundown of how this works. We have 3 hot technologies. We're going to put them on the clock for 15 minutes each, and at the end of each presentation, we're going to do a drawing for an awesome prize. If you're the lucky winner, we're going to email you after the webinar to arrange for delivery, so you don't really even have to do anything. Just respond to our email. If you have any questions during the webinar, please submit them in the Q&A box. In the last 10 minutes of the hour, we're going to answer these questions. All right, so we promised 1 hour, so we'll jump right in. Up first, we have Aaron Gibson with Cloudian. All right, Aaron, I'm turning over the controls to you. Aaron, we're not hearing you. Sorry, folks, give me 1 moment. Okay, we're all set now. Aaron, sorry about that.
That's okay, thank you. I was stuck trying to unmute myself. All right, so I have with me Warren Halliday, who's the Regional Sales Manager, and myself, Aaron Gibson, Senior Solutions Architect for Cloudian here in the Texas region.
So we're going to just give you a very quick overview of our technology and where we fit in this Nutanix Rubrik Cloudian mix. Just won't take but a minute. If there's time remaining, Aaron's going to give you a quick overview of our sort of a quick demo and look at our CMC, which is our Cloudian Management Console. But Cloudian, there we go. Where we fit is in the realm of unstructured data, and it comes from everywhere. In this case, we're going to be talking about a deep but active archive for backup data that's pushed to us from Rubrik. But we also, wherever there is unstructured data that is not being processed but is needs to reside in an archive, that's where we fit. It could be surveillance video, it could be backups, it could be archives of analytical or data that will be analyzed or processed, but that's pretty much where we fit. Customers use us because we're 100% S3 or within 5%, 95% S3 compliant, which is Amazon Web Services. Their APIs are based for their simple storage service. If you go to Amazon and look for capacity, you're going to use the S3 protocol. And we are fully compliant with S3. But we also offer up enterprise NAS features. So we have gateways that ship with all of our products for both NFS and SIFs. People use us because we can start as small as 50 terabytes and scale to exabytes. We're able to do all of our manipulation on a bucket by bucket basis in terms of how we protect it and where we move it, those kinds of things. We have gateways in our system so that we can cloud out by policy to any of the public clouds, including AWS, Google, Azure. The fewest replicas that we have are 3. So we're very, very resilient, shall we say. We talk about 14 nines. Once the data gets to us, it's never going to go away. And our cost very quickly falls to about a half a cent per gig per month, which is very similar to what you would see from even Amazon Glacier. So, Aaron, do you want to talk about that?
Yep. So we have a number of customers that have deployed us where they're utilizing Nutanix for the virtualization engine, then having automated backups done through Rubrik, being able to provide all the functionality that they'll speak about. But then Rubrik also has the ability that it can, by policy, archive those out to on-premise S3 storage. So pertinent to this discussion today, the three of us work really well together, being able to provide a long-term archive backup target to run your environment. Now, we also offer the ability, as Warren had mentioned, that we can tier that data out to any public cloud from there for even longer-term archive. So this is kind of an example use case of how we can be deployed together. So with Cloudian, there are two different products that we sell. One is Hyperstore, the other is Hyperfile. For both of those, you have the choice of purchasing appliances from us or doing a software-only deployment, so buying a software license from us. We can get into more details with anybody who's interested on those. On our appliances for Hyperstore, we have nodes that can go up to about 840 terabytes of capacity in a 4U space. Gives us a lot of scaling options to be extremely dense. And similarly, on the Hyperfile side, we have appliances that we can use there to give us additional high availability and performance requirements that you might need in your environment for archival NAS use cases. And with that, we'll move over to hopefully a real quick demo. So all I've done here is I've logged into our online demo system. It is a live system. It does have all of the metrics that we typically see in a customer production deployment. This is all running in a virtualized environment in this demonstration. So our dashboard, once we log in, gives us a quick summary of how much capacity we have total in the environment, how much is free, and how much is being used of that. You'll notice that we can click into any of the items that are here and get additional details, so drill into the statistics of the environment. To the right of that, we can see what our trend has been of our usage of the capacity and a forecasting of where it's going to be in the future. This gives us the awareness to know when we need to purchase additional storage or maybe make a change in our consumption habits so that we don't overrun the system. Below that, we have a quick view of the health of the cluster. So we do have some warnings in this environment that we have high put and get latencies. It's quite common for this. It doesn't have a lot of resources allocated to it, so we do see some laggy responses. But overall, we don't have any other warnings or alerts that have come off of this system. We can see over here, and we can scroll through and see what those values are, the latency values that have occurred over time for reads and gets. And then to the bottom left, continuing down, we have some nice stats about number of users the system is managing, total number of groups that represents, total objects that have been stored into the system, how many nodes and how many data centers this currently represents, and always important, what version of code we're running on. For some of the long operations that we might run in the environment, this gives us a quick view of the status of those and whether or not they've completed successfully or not. So when we add nodes, remove nodes, we would go through processes to do repairs and cleanup just to redistribute and rebalance data across all the remaining nodes in the environment. So, like I said, if we click into any of the graphs that are there, it does give us the ability to see additional details about where our capacity is coming from. So this graph is a little bit different than most environments where you might see things, but it's showing us an overall capacity that we have. Then we can see how that's broken out into the two individual data centers, and then going so far as to determine which of the nodes is providing what capacity. So this is a great place for me to point out that not all of the nodes are providing the same amount of capacity. So this particular one's providing 24 terabytes of space, while one of its peer nodes is only providing 8 terabytes of space. We do not require that all systems be identical. whether that's within a data center or across data centers. So this gives us a lot of flexibility to grow and expand however makes the most sense in your environment. So allowing us to start extremely small, but scale into very large, very dense capacities over time. One additional piece I'll show here. So this gives me kind of a visualized view of my environment. I can see quickly that each of my nodes is responding with some type of an alert. Again, for this environment, quite normal. But I can also show here that I have the ability from our management console to add an additional node, add an additional data center, or even go so far as adding an additional region. So if I need to have complete separation of data between physical servers and locations, I can deploy multiple regions and manage all of that within the system. I can also showcase here that in DC1 for this environment, we have 5 nodes versus 6 that are operating in our DC2. To get a quick glance of services that are running and the health of everything, we can see that our core services are running on every single node, and our secondary services that operate in traditional master-slave or failover pairs are running as they should be as well. So one key difference about Cloudian and how it deployed or built its solution for Hyperstore, it is built on a full peer-to-peer model. There is no primary service that runs as a master node. So every node is capable of servicing an S3 request. Every node is capable of being accessed for the management console. There's no master within that set of services. Clicking into any individual node, I can get additional details about it, as well as statistical information about its CPU, disk utilization, memory utilization, and network utilization. So I can go through and I can drill into the individual disk drives and see what my capacity and consumption is on those as well. In the event one of these disks had failed, this green icon will change to red, and I'll be presented with options that I can choose to replace the disk with a new disk in the environment. With our appliances in use, you'll actually get a graphical representation of the appliance with front and back view, and the ability to go in and turn on the indicator lights for disk drives. So you can have somebody that's remote be able to go in and look for the disk that needs to be replaced or the node that's got an issue occurring on it so that they can do troubleshooting for you. Similar to how we do our breakdown for disk information, we also provide memory details for our core services so we can see what the consumption is, be mindful and aware of any possible out-of-memory situations that can occur. And then at the bottom, we get to see the services for this individual node, the ability to restart them, stop them, and further at the bottom, we can see the individual alerts that have occurred on this particular node. So we can acknowledge that, and that would put this node back into a green and healthy status. We could then further go through any of the additional nodes that are here to check and review what's going on with those nodes in the cluster. Let's see. Before I get cut off here, just to reiterate, something that's kind of unique for us is the ability that protection of your data is by policy and how you want that to be. So we have multiple policies that exist on the system as it is already. But you have the flexibility to choose, do you want that data to be replica-based protection, or do you want to do erasure coding protection? Do I want to store that within a single data center or within multiple data centers? And then for each bucket I create, I'm able to then choose which storage policy I want for the protection of the data underneath it. So I would give this a name, give it a description that I would like to use, determine how many data centers I want to have my data distributed into, and how I want that data to be protected in those. So it's defaulted here with 2 data centers doing 3 replicas, and I would be able to come down here and choose which data centers I want for those replicas to reside in. If I wanted to be more efficient about my consumption, I could come back and say, no, I want to do replicated EC. I would pick my erasure coding value. Think of this as being like a RAID 5, RAID 6 type concept. We have parts and we have parity to protect that. But I would choose which data centers I want for that. In an environment that has 3 or more data centers, we also give the ability to distribute that erasure coding data across data centers. So no single data center has a full view of the object, but gives us full fault tolerance in the event that a data center goes offline, while providing still a high level of efficiency on the raw capacity provided by the individual nodes themselves. again with a couple of options for defaults that are available for erasure coding here. At the bottom, we can choose how we want to respond to client requests. I will just iterate that an all option, while available, is not commonly used. This would require that every single node must respond for a given request. If for some reason they can't, the request would be failed. Quorum is what 99% of customers utilize, and this allows for faults and failures within the environment, whether that be a disk or a node or potentially a data center. Quorum just means I have to have a majority of those nodes respond. For anybody who's interested in a multi-tenanted environment, we can set these policies such that only certain groups of users are able to see and manage data in this particular manner. So I can come in and designate that the Cloudian group is the only one able to use this particular storage policy. I could then create an additional group, additional users within that group, and restrict them to a different storage policy themselves. We can do compression of data. Now, in the Rubrik scenario, Rubrik would be doing all the deduplication and compression of information. So this may not yield you anything, but for additional use cases, we do offer compression that can be turned on. We do have the ability to do forced server-side encryption. So regardless of whether the S3 request came in requesting for server-side encryption, we can enforce that that be done with just internal key management, or key security allows us to use an external key management system to encrypt all of the data. And with that, I believe I'm at my time.
Just wanted to throw in the fact that we can do very quick and easy POCs using VMs. We need 3 VMs. We can load them up with OVAs and have an environment, a Cloudian environment running in your environment in just a matter of 30 minutes to an hour. So that's pretty much all we have.
Thank you.
Awesome. Thank you, guys. All right, so we now have the drawing for our first prize, which is the Bose SoundSport free truly wireless headphones. Let's see here. All right, and the winner is Jignesh Trivedi. Congratulations, Jignesh. We will email you after the webinar. All right, up next, we have Jason Burrows with Nutanix.
All right.
All right, Jason,
Very
you have
good.
control.
Can you hear me well?
Yes.
Awesome. All right. Well, thanks everyone for joining us, and I really appreciate you setting this up. I'm going to jump into a little bit about Nutanix. My name is Jason Burrows, and I'm the systems engineer for mostly for the state and local government, paired up with Dito Guerra. So we work within the state of Texas and kind of surrounding geographic districts. So let me show you a little bit here. So Nutanix is an enterprise cloud company. Let me move this control panel. Pardon me. All right, here we go. So, we've been around since 2009. We've got about 8,000, 9,000 customers, 3,300 employees. And, recently we had the honor of being awarded the Gartner Magic Quadrant leader in the hyperconverged space. So, very proud of this. This is a pretty major milestone for our company to be awarded this within the leaders quadrant, right up there to the top and right. #1 companies within all of these different categories all run on Nutanix. So just give you a little bit of flavor of, been around a while. We've got a pretty decent amount of customers out there using our products and enjoying it. What are we here to talk about today? The IT world has gone through a big transformation with the cloud. Users demand it much faster than they used to. So IT is now trying to keep up with their users' expectations. Some people call that the consumerization of IT, where people demand the same kind of user interfaces and experiences that they get on their home electronics and their personal mobile devices and things like that. That's things like fractional IT consumption, being able to pay for just what they need and not, amortizing something out for many years. Things that are very fast to market, deploying an application very quickly, getting new updates very quickly. Most people's first experience with the cloud is, of course, the public cloud, such as AWS or Azure or GCP. Those users start to want that same experience in the private cloud, which would be the on-prem enterprise equipment. And then we're also seeing a big push towards what we're calling the distributed cloud. That's things like cruise ships or oil rigs or self-driving cars and autonomous vehicles, things where you have a lot of compute at the edge. So what we're trying to do is create a cloud operating system that has a unified system of management across all of these platforms. Same operating system, same stack from one to the other. So how we do that is with a series of products. We've got a suite. We've got Acropolis, which is our HCI, the Hyperconverged Infrastructure technology that we're the market leader with. Prism, which is our management interface. Flow, which is our newly just about to be announced software-defined networking stack, as well as Calm, which is an application automation platform, and then Xi, some of our forthcoming native cloud services, such as DR as a service, which we'll be talking more about later this year. So customers have the ability to consume this in multiple ways. We have a traditional appliance, just a standard x86 server running our software. We have the ability for customers to deploy our software on their hardware within our hardware compatibility list. And then going forward, we have some cloud services related to our own hosted public cloud. So you may be familiar with this stack where you've got networking, you've got servers, you've got storage, perhaps a storage network. Got the virtualization layer on top. So what we've done is we've taken that core server storage piece and hyperconverged that. So instead of having a SAN or a NAS, you've got your storage built in directly into the server chassis, and that scales out. So you put the hypervisor on top of that. We support all the major hypervisors. A couple of years ago, we released our own hypervisor called AHV. It's forked from the popular open source KVM hypervisor. And it's a very high performance and secure hypervisor that was built to meet the needs of especially the federal government early on with some really stringent security requirements. And it's license free. It comes with the platform. So we also have a very simple and easy to use GUI. We've got this Nutanix Flow software, which is the core is based around micro-segmentation as well as security. So this is not a full network stack that's designed to replace a company's entire network. It just offers some enhancements. Specifically, the first foray in that is micro-segmentation to prevent some of the malware and things like that that have been pretty rampant recently. So we've got our automation orchestration stack called Calm, which allows you to create blueprints. You might think of it like a Chef, Puppet, Ansible, VRO, VRA kind of. It's in that genre of applications. And then finally, we have the ability to manage these Nutanix devices, whether they're on-prem or in the cloud, connecting resources between both. So what type of workloads run on Nutanix? Pretty much anything in a data center can run on Nutanix. Anything in the cloud can run on Nutanix. These are your core virtual workloads, all your tier 1 applications, your robo environments, everything that you would typically virtualize, you could run on Nutanix. Now, in addition, for those customers that require a SAN that's connected over something like iSCSI or Fiber Channel, we do offer iSCSI services for bare metal applications. Sometimes people use that to reduce their Oracle licensing footprint if they haven't yet virtualized those applications. In addition, for customers who need file services, such as CIFS or NFS, we offer a NAS gateway. It's a filer built directly into the system, so it's a virtual machine that offers those services. And then the cloud native stuff, sort of like Kubernetes and Docker, where you've got containers and you've got a DevOps workflow. So all of these workloads can run directly on the Nutanix hardware and software. So we manage this through Prism, which is our HTML5 web-based management interface. I'm going to try to do a demo here right at the end for a few minutes. This is built from the ground up. If you're familiar with VMware, you might know some of the story there where they had the thick client and then the web client, and now they've got an HTML5 client. It's not yet quite feature complete. We started from scratch with the HTML5, so we didn't have as many of those hurdles to jump through. No Java, no Flash, no security issues, and client integration plugins and things like that. So it's really easy to use GUI. So one of the things about Nutanix that you really want to keep in mind if you're comparing us to others in the hyperconverged space is the word choice. You can see here all the different ways to consume this service. You've got your choice of hypervisor, Zen Server, Hyper-V, VMware, and our own AHV. You can use any of these platforms, our own hardware platform, which is based on Supermicro, or we have also an OEM relationship with Dell and Lenovo. And then we have a meet in the field relationship with Cisco and HP, where you can install our software on their servers. as well as IBM. We have a new OEM relationship with IBM for their P series, their power series. So if you have some high performance Linux workloads that run on that, as well as AIX, if you virtualize AIX, you can also run that on Nutanix. So as far as the cloud goes, if you want to connect us to AWS or Azure to do your backups to cloud, you can do that. Google Cloud Platform support's coming later this year. And then we're launching our own Xi Cloud Services, which is a Nutanix hosted public cloud specifically for DR as a service. And that's all I have for the slides. Let me jump out of this and I'll show you a quick demo. Okay. So this is a demo site that we can log into to show real life system. We've got hundreds of systems running in our San Jose offices, running demos all day for our customers. So if you see a burp or a hiccup here, it's probably going to be somebody else deleting something that we were about to show you. So when you log into Prism, what you see here is a few sections. You've got the summary, and then you've got performance, and then health, and then alerts. And one of the things I want to key in here is the performance. In VMware, for example, you really have to hunt to find the performance statistics. They're not exactly front and center. What we've done is just about every screen you go to in Prism, you're going to see performance statistics. It's a nice way to see exactly what's going on without having to create a custom report or install third-party software. So here we see we're running AHV, our hypervisor, how much storage you have, how many VMs you're running, and then the hardware summary. So in this case, we have one block, which is essentially one chassis, one server chassis that has 4 hosts in it, 4 little servers running in that one block. You can see here we're using about 10% CPU and 80% memory. So if we go up here to VMs, you're going to see the summary, and then in the table view, you'll see all the active VMs. So for example, you can sort right here by performance, and we can see which controllers, which of the controller IOPS you're going to see the most on, or bandwidth. So if you scroll down a little bit, you're going to see the performance for each of these items, and you can drill all the way down into the IO metrics to see, is this sequential IO, is it 4K random reads, 4K random writes, what's your latency? So that's a really key metric when you can look at the latency that's on the systems. You can see here one of these systems has 1.85 milliseconds, so it's an extremely low latency type of system. Also over here, I'll show you on the storage tab where you can see the data reduction. In this case here, whether it's dedupe, compression, or erasure coding, we offer all the basic technologies to reduce your data footprint, save you a little money. Overall efficiency, you see it's 10.8 to 1. The reason we show these 2 different numbers is some vendors include their snapshots in their data reduction. We don't really do that. We don't show that. So we would like to say this is our real number. However, if you want to look at it, including snapshots, so we can be more on par with what some other vendors say their product is capable of, we also have that higher number, which is, in my opinion, a little bit artificial. So let's see here. Let me also show you a planning tool that we have. This is a capacity planning tool where we can look at how much storage capacity and memory and CPU you have in the system, and then you can model it. So in this case here, you can see the trend over time is such that eventually you'll run out, but because of the system being a demo and there not being real stuff on here, you're really not going to run out of resources for a long time. But what you can do here is you can plan for an additional workload. I think there's probably already some people who've been in here. So yeah, you can see this here. So somebody says, well, what happens if we add a SQL server in June? Okay, well, suddenly you're going to run out of storage, memory, CPU at that point. So we have a button over here to say recommend, and it's going to say, okay, in addition to what you have, you should also add 3 new nodes, 1065s, that's the model number, this much memory, this much storage, and now you're good to get you past another year. You can click a button to generate a PDF, take that PDF to the boss and say, hey, we really need to get this new storage server compute before we add those new SQL resources. And so this is our management GUI, and that's all I have to show you today. Thank you.
Great, thank you so much, Jason. Let me just switch screens here. All right, perfect. So our next prize is a Samsung Gear smartwatch. And the winner is Matthew Miles. So congratulations, Matthew, and we will email you once the webinar is over. Our final presenter is Glenn Spear from Rubrik. Let me turn over to Glenn here.
All right, here we go.
Perfect. It's all you, Glenn.
Okay, y'all can see me?
Yes, you're good.
All right. Let me minimize this. Oh, here we go. Okay, thank you very much. My name is Glenn Spear. I work for Rubrik here in Austin, Texas as a senior sales engineer. I came here about a year and a half ago. Rubrik's been on the market now for about 3 years, roughly, selling product. We're a data protection company. We call ourselves Cloud Data Management, as we can help customers as they need to protect their on-prem data, as well as when they move data to the cloud and in other areas. We share a lot of, listening to Jason about Nutanix, we share a lot of DNA from Nutanix. Our CEO was actually one of the initial investors in Nutanix. He saw the potential for that type of technology, that converged type technology, where you take multiple aspects of your environment and combine them down into one device, one fabric. He saw that technology and the potential, and he decided to apply it to backup and recovery data protection tasks. And that's what we've done here at Rubrik. My goal here today is to give a quick overview of what we're doing. I kind of let you in on the vision of where we're going, and then if we need to dig in further later, we can. So in order to show you what Rubrik is doing today, I do a little bit of a time warp. Really, data protection hasn't changed at all since the early 1990s. All the products out there today that you might be using, like Networker or NetBackup or TSM, which is now called Spectrum Protect from IBM, ArcServe, Backup Exec, Commvault, all those products really share this same architecture. You have backup servers that have software installed on them. You have a master server that kind of manages everything, and you manage jobs through that. You've got media servers or media agents, and they call them different things, but they're basically data movers. They're attached to some type of backup media. That backup media could be tape, it could be disk, could be dedupe disk, something like data domain or something like that. But all in all, the architecture has been the same since the early 1990s. Nothing's really changed. There's a lot of complexity in these environments. From all these components, most of these components come or can come from different vendors, so you may have 3, 4, 5, even more vendors associated with your backup stack. What we've done is we've taken all those components and put them onto a single scalable fabric. Our customers consume that fabric via a couple of different methods. Most of all today, it's our appliance, similar to the appliance from Nutanix. They call theirs blocks. We call ours bricks, just play on the name Rubrik. So each brick contains 4 nodes within it. We can also deliver our technology on OVAs, so out for your VMware environment, just virtual machines or even cloud cluster appliances that can sit out in AWS or Azure or Google Cloud. And we scale this fabric. As you scale your environment, we just add bricks to the environment, and it automatically scales the compute, because each one of these nodes, there's 4 nodes within each appliance. Each node has its own compute, it's got its own storage and its own flash tier. So as you add bricks to the environment, we just add capacity and compute to the overall environment, and so we're very easy to scale. For long-term data retention or offsite requirements, we can send data out to any public or private cloud appliance or service. So we can send data out to AWS or Azure or Google Cloud platform, or if you want to keep data on-prem or send data maybe to a DR location, you can do private cloud. So devices like Cloudian, as was mentioned before, we can send to S3 or NFS storage. We can even go to tape if you really need to, but hopefully most everyone's moving away from tape now. How do we work? So when we went to market initially, we supported primarily VMware, so the predominant hypervisor of the time, VMware. So we were able to protect VMware data and send that data out to AWS for long-term retention. That was really all. So if you haven't talked to us in a while, we're doing a lot more now. We can do VMware data, we can do Hyper-V, we can do Acropolis, so we can tie in with Nutanix environments. We can back up SQL Server natively. We can be a target for Oracle RMAN backups. We can protect NAS, Windows, Linux, even AIX today. So we can manage many different platforms. Quick start, so kind of how we work and how we get our foot in the door is we're very easy to configure initially. Usually we from rack to actually backing systems up 15, 20 minutes. It's very simple. Point to your hypervisors, automatically discover systems, and apply what we call SLAs to those systems. So no more job management, no more scheduling. We set these SLAs, which define how often you want to protect systems, once an hour, once a day, once every 12 hours, whatever you want to define, and then how long you want to retain the data. And then you apply that SLA to systems. So no more job scheduling, job management. We ingest data in parallel to the different nodes, and whether it's in our physical appliance or cloud cluster or OVAs, we do parallel ingest over 10 gig pipes on the appliance directly into our flash tier. So you get really good performance, really good backup performance. We do a single full backup for any data type we protect, single full backup, and then block level incrementals forever after that. So no need to pick whether you're going to do an incremental or differential or full or synthetic full or reverse synthetic full or active full or all those options that you see with the other vendors that are out there. We just have that single backup method, single full backup, and then block level incremental forever. Instant recovery, our customers love our ability to instantly recover virtual machines, so you can live mount from our device. We present as a data store to Hyper-V or to VMware. So you can run your virtual machines directly off of our appliance. We're the storage. You still leverage your compute environment. We leverage our flash tier not only for that rapid ingest that I talked about before, but for really fast performance, really good performance for your instant recovery. So we serve up the virtual machines out of our flash tier, so you get really good performance from it. We can even live mount SQL data. So whether SQL is on a physical system or a virtual system, we can present as an SMB3 share to your SQL systems directly. And you can mount a SQL server. We've had customers with very large SQL servers in the 10 terabyte range that were able to mount those databases and have full access to those databases within 2 minutes. So very fast performance on our recoveries. Security, end-to-end encryption. We have even a hardware encrypted device that's FIPS compliant. The data we write to our device is immutable, so even in the event of ransomware hitting your company, we can go back and find the last known good version of a file down at the file level and pull that information back. We've written scripts for customers to automate all of that. And finally, cloud. So customers are either thinking about cloud or maybe they have a hybrid cloud approach today. We can help them, help you as a customer as you want to move out to the cloud on your cloud journey. We can do things like cloud out. So cloud out is just archiving data to cloud for long-term retention. Pretty much everybody does that today. But we can also take that to the next level. If it's VMware data or Hyper-V data, we can automatically convert that data, those virtual machines, over to AWS or Azure virtual machines, and you can launch those automatically in the cloud. We can also protect cloud workloads. So as you have workloads that actually move into the cloud, we can install our software on cloud devices, on the virtual machines that are sitting in the cloud, and protect the data within that cloud provider. So you're not having to move data back and forth, back on-prem to protect it. So throughout your cloud journey, we can help you out. So just to kind of recap, your data center today, you've got backup servers, you've got proxies, you've got media servers, you got disk and tape, and maybe offsite even vaulting data to Iron Mountain or something. We take all those components and collapse those down into a single scalable device that can be easily scaled out by just adding devices. Masterless share nothing architecture, so full fault tolerance across the entire fabric. And as you scale out, you can move data out to public cloud, you can move it to private cloud, you can move it out to devices like Cloudian. So you can have that long-term retention off of the Rubrik device, putting it somewhere that's more cost-effective, or getting that data off-site if you need to. You can also replicate data between Rubrik devices if you want to put another Rubrik device at a secondary site, or we can do that as well. So finally, to wrap up, mentioned before the ability to protect cloud workloads and leverage cloud. We support Amazon, Microsoft Azure, and Google Cloud Platform today as our public cloud providers of choice. You can move data to those from Rubrik out into those tiers. Again, that's called Cloud Out. That's for long-term retention and offsite. But we can also move data, and this is kind of our vision as well, move data between cloud providers. So you're no longer concerned with where you put your data today and whether or not that's going to be the most cost-effective location for that data tomorrow. We can help you move data between the cloud tiers as business needs, as costs, et cetera, change for those cloud providers that are out there. So finally, we're easy to manage, easy to deploy, so easy to put out there in the beginning, and then our SLAs make it very easy to manage our solution. We're easy to scale, so if you're a growing company and growing your backup stack is heartburn for you, we can make that a lot easier by just allowing you the ability to add nodes, add bricks to scale your environment. We automatically add those into the fabric, and you're off to the races. And finally, ultimately, we save our customers money. So you have all these additional capabilities and all these things that make life easier. Ultimately, based on the customer costs for all those different components of their backup stack, ongoing maintenance costs and refresh costs of the hardware that's associated with it, et cetera, we can usually save you money if you have a sizable backup stack, a sizable footprint. So it's worth having a conversation with us to see if we can actually even save you money in addition to giving you all these additional capabilities. So that's it. That's a wrap. If you want to dig in any further, of course, reach out through Freeit, and we can set up a deep dive and additional demonstration and things like that. Thank you very much.
Perfect. Thank you, Glenn. Okay, so for our final prize, we have the, oh, sorry, that's the wrong picture. There we go. The Amazon Fire HD10 and Cloud Cam. And so the winner of this is Min Tran. So congratulations, Min, and keep an eye out for that email. All right, well, that's it for our presenters. We do have a couple questions here, so let's see what those are. All right, it looks like this is for the Cloudian guys. So which version of NFS is supported? And then also, how is licensing handled? Aaron, can you answer those for us?
Yeah, so today we support NFS version 3, and as far as licensing goes, we do license based on capacity. So it's based on per terabyte usage of data received.
Perfect. That's all the questions that I have in the box. If you have any other questions, please submit them now and we can get those answered. If not, we can go ahead and wrap up. I know it was a quick overview, but if you'd like to hear any more, feel free to reach out to myself. My